This is the tutorial for Chapter 4, Section 4, Graphing Functions. So yesterday we graphed functions that were linear. So linear equations form straight lines. Linear equals a line. And so you know it's a linear if it's in this form, y equals maybe like a 3x plus 2, where x is just to the first power. So we have it to the first power, and then also y is to the first power. And so we see both of those are to the first power, and so whenever it's just an x and just a y, that's the way it's going to be. Now this one is an absolute value, so the absolute value is going to end up forming a v, forms a v, and so the graph will look something like this, where it ends up just making that. It has straight lines, but then it comes down to a bottom point of vertex and then comes back up. And it could end up looking a couple different ways. It could end up being upside down depending on the sign that is in front of the absolute value bars. Where if it's an x squared, like this one here, so whenever we have x squared, it forms a parabola. And so a parabola is a U-shaped graph. And so it looks like this. And so it's either going to be a right side up parabola, or it's going to end up being one that opens down like this. And then we have x to the third. And a cubic function forms a graph that's going to end up doing something like this. It's going to end up either it's going to go up or down, but it ends up having a little hook in there where it changes, and so it goes up fairly quickly, but then in the center it ends up kind of leveling out, or it could end up going the other way, where it ends up going this way instead. So that's the type of graphs we're going to end up seeing. So linear to the first power is going to end up being a line, and you can check out how I did those on the first day's tutorial for Chapter 4, Section 4. And when we have absolute value, v x squared, it's going to end up forming a U-shaped, either up or down, and x to the third forms one of these types. So let's take a look at the first one here. And so what we're going to end up doing is, now I've got an understanding about what it's going to look like. So I want to try to pick some values that are going to give me that shape. So sometimes we have to pick more than 3 values to really get a good understanding about what the graph looks like. So I'm going to write in my inputs, my function, and my outputs. And so I'm going to try a couple negative values. I'm going to start with -2. And when I do that, that's going to end up making a +2 plus the 1 gives me 3. And if I try -1, that's going to give me +1 plus the 1 gives me 2. 0 is going to make the absolute value 0 plus the 1 makes the 1. And then when I get 1, well, 1 plus 1 makes 2. And when I plug in 2, I get another 2. So absolute value of 2 is going to be 2. Absolute value of 1 is going to be 1. And when I get those numbers, notice how we see that shape where the y values start to descend, but then they get bigger as we go. So when I plot these, -2 spaces over, 3 spaces up, and then -1 space over, and 2 spaces up, and then over 0 and 1 space up, and then over 1 and up 2, and over 2 and up 3. So now we've got that V shape, so we know that's what it ends up looking like. So it bottoms out right there at 0, 1, and then it continues up. Arrows at the end signify the line goes on forever in those two directions. Here we've got the opposite of the absolute value of x squared. So again, we know it's going to form that U-shaped graph, so I really want to get a good understanding about what that looks like. So I'm going to pick enough points to be able to understand that. So I'm going to start with -2. Now when I do -2, that minus sign on the outside means the opposite of. So I've got to square -2 first, then take its opposite. So that's going to give me -4. And then I'm going to go to -1. So opposite of -1 squared. So that makes 1, but then the opposite makes -1. 0, well, opposite of 0 is just going to end up being 0. And then 1. Well, when I square 1, I get the same thing as -1, which is just 1, but then I take its opposite, and that's why it makes -1. And then I plug in 2, so the opposite of 2 squared So that's going to make -4. So once I've got those points, plot them. So over 2, and then to the left, and then down 4 spaces. Over 1 and down 1. Over 0, down 0. And then over 1, and then down 1. Over 2, down 4. So I end up getting this U-shaped graph. So anytime you've got the x squared, that's the shape that it should end up taking on, is this U-shaped graph. And that's the parabola, opening down. And so x to the third, I know it's going to form something like that. So let's go ahead and plug in enough points to be able to make that shape. And so I'll plug in the function in the center here. And I go ahead and pick some points. I'm going to start with -2. And when I do that, it's going to end up being -2 times -2 times -2. So that's 3 -2, so it makes -8 minus 3 makes -11. A -1 would make -1 minus 3 makes -4. And then if I plug in 0, that's just going to give me that -3. And then going to 1, well, that's going to make +1 this time. And then -3 makes -2. +2, well, that makes 8. And 8 minus 3 makes 5. So it looks like I've got enough points here. Now, I can't get down all the way to -11. So what I'm going to do is I'll go ahead and we can change the scale of the graph. And I think I'm going to do that. I'm going to go by 2's. So I'm just going to write down 2's here. And I'll go by 2's here as well. So I'm going to go over 2 spaces to the left. So this is 2 right here, 2 spaces over, because I'm counting by 2's. And then down 11, so that's 2, 4, 6, 8, 10, and so 11 is going to be about right there. And then over 1 space, so it's going to be right in between the hash marks there, and then down 4, so 2, 4. And then over 0, down 3, so it's 2, 3 is right there. And then it is over 1, and then down 2 spaces, puts me right there. And then over 2, up 5. So 1, 2, that's 2, 4, and 5 puts me right there. So that's what our shape ends up looking like. So we should always get this shape where it's continuously going kind of up from left to right, but it goes really quickly, but then kind of levels out, and then it goes quicker again. And so that's what our shape ends up looking like. So that's what you're going to see with those problems. So you should always see those 3 shapes with those 3 different types. If it's just a line, it's just to the first power. Let's take a look at our last problem that we'll see. And this is one in which we are trying to graph a situation where we end up using a squared function. And so it says the height h in feet of an object that falls can be modeled, and spelled a little wrong there, but it's okay. And then by the equation h equals d minus 16t squared, where h is the final height, and I've got d equals the initial height, and t equals time in seconds. And so what I'm going to do is find the time in which the object will hit the ground. And so the ground I represent as 0 feet. And so that's what I'm going to set h equal. The final height is going to be 0 feet. So we're going to take our formula here. H equals, and then d minus 16t squared. And I'm going to put 0 in place of the final height. D represents the initial height, so 300 feet. So it was 300 feet up, so I'm going to put 300 right there, minus 16t squared. So all I'm doing now is I want to find out when this height is going to end up being 0, and so I'm going to substitute some numbers in. So t is going to be some values I'm going to put in for seconds, then my equation, 300 minus 16t squared, and then I'm going to come up with values of h. And so I go ahead and plug in some numbers. Now when I do this, I'll start, I can't have negative numbers for time. So time must be positive. So I'm going to use positive numbers. So I'm going to start off with 0 though. And so when I start off with 0, you see how it's going to make 0 squared as 0 times 16 would be 0. So you can see I'm starting 300 feet up. And that's what it said. But then after 1 second, let's see where we end up getting. So I have to square 1 first, which is just 1, and then take 16 away from that. And when I go ahead and do that, that's going to give me 284. And so from there, I end up plugging in 2, and now I still have that 300, but this time I have to square 2. And so this is where we have to be careful. So we've got to multiply 16 by 4, and in that case, we're going to end up with 64, and then I've got to take that away from the 300. And so that's going to give me 236. And so from there I have 3. And so I'm getting closer. I'm really close to that height there. And so let's see here, 236. And well, I'm going down further, that is. So now I plug in 3 for that. So it's 16. But then I've got to square the 3. So that's where I'm getting 9 from, times by 16. So now the numbers are getting much bigger here. And so we're going to pull out this calculator and do 9 times by 16 makes 144. And so I've got 144, and then I've got to take that away from 300. So 300 minus the 144 gives me 156. So you see I'm going down much faster now. So I've got to continue though. So I've got 4 now. I'm going to plug in, so 300 minus, and then I've got to do 16 times 4 squared. Well, 16 is what I get when I square 4, and that makes 256. So that makes something really close there. So 16 times 16 again was the 256, and I'm taking that away from 300, and so that made 44. So I'm almost down to the ground here, so let's go with 5 seconds, see what happens there. So I'm subtracting, and then 5 squared makes 25, so I have to do 16 times by 25, and that gives me 400. So there I'm already past the ground. So you see how that makes that negative 100. So I know it's in between these two. So somewhere in between 4 and 5 seconds, the object hits the ground. So I just wanted to graph that just to give an understanding about what that looks like. So I'm going to maybe call this one 100 here. Let's see if I can fit it there. So this would be 200. So let's go with something a little bit different here. Let's call this one 100. We'll call this one 200 here, and we'll say this is 300. So 300 right at this point. And so I'm going to go by, call this one 1 second here, and this is 2, 3, and 4, and 5. So this is 2, 3, 4, and 5. And so I'm calling this time in seconds, and this is height in feet. And I got time. And so what we're going to do is start at 300 at 0 seconds, and then after 1 second it was down to 284. So there's 250, so 284 is going to be somewhere up in here. And then at 2 seconds it went down to 236. So there's 250 again, so 236 would be below that, somewhere in this region. 3 seconds it was at 156, so there's 150, so just above that line. And then after 4 seconds it was at 44 feet. So it's going to be somewhere right in here. And then after 5 seconds, well, it's negative 100. So just plotting that point, even though that's not a value, it kind of gives us an understanding about how fast that line or this curve ends up descending. And so that gives us a better clue. So if we kind of head towards that line, that's where we're going to end up meeting. And so it's going to be somewhere closer to 4 seconds than 5 seconds, somewhere in that range. So those are the types of problems you have on tonight's homework. Good luck.